Hello, dear student. Assalamu alaikum. It's me, Dr. Sami, your GIS tutor. So I'm going to welcome to the class of GIS and remote sensing. Before going into detail of the class of GIS and remote sensing and its syllabus, as the contents of the syllabus, first we will take to have a start with the definition of GIS. So actually, if you go to GIS, it's GIS. So GIS is simply like G stand for geographic, and I stand for information, and S stand for systems. It's something like that. It's a system which is based upon the geography information system. Geography, I mean any area, say geography, which give you about any area or any object, about the information of any objects or any area, where it can be water bodies or maybe a forest land or maybe agricultural land or maybe glaciers. So which give you information about the geographic location with lat and long of water bodies, agriculture, forest land, people, habitation, whatever. That's something like it's called geographic information definition. So as you see that there are a lot of definitions of GIS, and many people have defined GIS according to their own context, because the foresters go with their own definition, the for agriculturists go with their own definition, the geographically go with their own definition. So there cannot be a single definition of GIS. So many people have defined GIS in different ways. For example, one of the famous personality in GIS is Aronoff, and he defined this GIS in 1889, that GIS is any manual or computer-based set of procedure used to store and manipulate geographically referenced data. So in this definition, there are involved any manual or computer-based set of procedures. Like a computer is something like a computer. You need a computer, and that computer will have the capability to store and manipulate. Manipulates mean to analyze the geographically referenced data. So in this definition, I will go for the three things. I mean, the first thing is that you need a computer for it. It can be a computer-based set of procedure. The second can be the computer has a hard disk or RAM, random access memory, where the data can be saved. And then for manipulation, you need a software. So the software also run on a computer, and also the geographically referenced data is something like the data having latitude and longitude information. A very simple example of this latitude longitude information reference data is Google Earth. I mean, if you put your mouse on Google Earth, you will have latitude and longitude information. So, but somehow I will give you an example of this software. For example, this is an arc map software. If you go to the if you open the data in our, so this is the computer, and I installed this software. So this is a kind of a computer set of procedures, and this software can open the geographically referenced data. With geographically referenced data, you can see I am bringing my mouse anywhere, and here at the base, it's a little busy. At the base, I have the latitude and longitude information. For example, look at this. This is east and this is north. So these are geographically referenced data. So a very simple definition of GIS is that it's a computer set of procedure which is used to store something like a computer which has a hard disk and RAM for processing the data, and manipulate, I mean something like to process the data, geographical reference data which have the latitude and longitude information. Afterwards, in 1889, again, this Oronov again made a very descriptive definition of GIS, and he also said that it's a computer-based system. I mean, you need a computer and software. There's a computer-based system that provide four set of capability to handle geographically reference data. For example, the first thing is this data input. For example, I have my computers, and this data is present on the hard disk. It's saved on the hard disk, and I'm opening this data. For example, this is one of the Landsat scenes of the Kalkot range of Dirkistan forest. So I open the data. So this is a kind of data input. So this is a geographically referenced data with latitude and longitude information. This data was saved on the hard disk, and I open the data in the software. So this is the first that you need the data input, and then it is the data management. This software manage the data. I mean the software that I just opened in front of you. This manage the data, and data management and retrieval. Retrieval means you can see this data on the software on the screen. So this is a kind of data management and data retrieval. And the third option is that manipulation and analysis. This software has the capability to classify the entire Landsat scene. Like this is for instance, this is forest area, and if you take a small sample from the forest area, you can easily classify the entire forest area. And this is, for example, agricultural land. If you take a small sample from the agricultural land, you will classify the entire agriculture. And this is suppose water bodies. I mean, this is the river Panchkoda. If you just take a small sample from the Panchkoda river, so if you take a sample from the entire scenes, a small sample even from some glacier or clouds, you will classify, the software will classify the entire image, and then you will have the information that how much area in hectare or in kilometer square or in percentage is present in the entire Dirkistan. So that can be a kind of data manipulation and analysis. And finally, it will give you the data output. When you classify this data, you will have a map. You will have a map of the entire scene. So that can be something like the data output. So it's a very good definition. Like data input, you input the data management, as we discussed, it manage the data, it store the data, and then it go for the manipulation and analysis. For example, if you classify the entire scene, you will have the area of different land cover or forest into hectare as well as in percentage. You will make a graph from it, you can analyze, and then finally you will have maps that can be a data output. The final output of GIS is map. Also, as I told you that there are many definitions of GIS, like cover is another good personality in GIS. He defined GIS that it's a decision support system involve the integration of spatially reference data in a problem solving environment. For example, it's something like that. It's also very good definition. If you have problem, for instance, we have a problem of deforestation in this area. So no, the problem arises, but we don't know where is the deforestation. So it's also very difficult if you just want to know physically going to this remote area. I mean, it's a huge area, a high area, and it's really located on a large geographical area. If you want to know about it, where exactly the deforestation is, it's very difficult. But if you open the satellite scene, for example, this satellite scene, you can see with the single eye view, you can have a look to the entire forest of the Kalkot range of Dirkistan. But if you also have a temporal date, for example, this satellite scene is might from, I guess, from 2019. But if you have another scene from 2009 or maybe 2000 or 1992, and then you can classify or maybe you can and then you can make the difference of this land use land cover. You will have the, the exactly that how much forest area is decreased, and you can also even create a change detection map from it, that where exactly these changes has been taken place. So when you know the percentage of land use land cover or forest deforestation and or the exact location of this deforestation, then you will go to a decision, and you can solve even the problem. So it also helps in a decision support system integration of spatially referenced data. For example, you have to use spatially referenced data is something like you have this data with latitude, longitude. You can even identify on the ground that where exactly the problem is on the surface of the ground. Because if suppose the problem is somehow on the higher altitudinal mountain where the human reach is difficult, you can even use a GIS and the satellites images, and you can analyze, and then you can even solve the problems in a problem solving environment. GIS will help you a decision support system in a problem solving environment, but that can be something like integration of the spatial reference data. The second option is this is the evolution of GIS, so it's very easy. I mean the evolution of GIS is specifically taken place. Before it was very difficult, but you know the computer technology is growing very fast, and that's also one of the reason of evolution. Remote sensing has brought revolution. I mean, if you go back to 50 or 40 50 years before, you will have maybe a few satellites in the atmosphere like these GPS satellites or maybe some Landsat satellites. But nowadays, you know, the entire globe is covered by a network of satellites, and you will have thousands of satellites from different countries which are getting information, or which are constantly looking to the ground for getting a variety of information. Also, due to the global positioning system, as I told you before, this was before only the DoD, Department of Defense System of US, was only the GPS satellites, but no, the Russia developed, the China developed, there are many GPS systems exist in the globe. So this, because of this improvement in the GPS technology, is also one of the cause of revolution in GIS. So communication technology is also, you know, before it was very rough and tough, but now the communication technology is very advanced. So that's also one of the reasons. And also rapid decline because of the computer hardware. You know, the computer hardware is constantly coming from different countries. The cost it declines. This is also one of the reasons of evolutions in GIS technology. Enhanced functionality of software, for example, as I remember, some 10 years before, I was only working with the RQ, but you know, I know, more than 20 software of ArcGIS or the GIS software, more than 20 GIS software. So you will have a variety of software like ArcGIS is one of the biggest, Erdas Imagine, like NV or QGIS, something like that. And even in some open source software, Recognition, and so there are a lot of software nowadays developed, so which is also one of the reasons of the evolution in the field of GIS. Okay, so as I told you that because of this evolution or the evolution of GIS text, because of the revolution in information technology like computer, remote sensing, GPS, communication technology, and also rapid decline because of the computer hardware and enhanced functionality of the software. Okay, if you go to the component of GIS, if I just want to show you that the GIS only need is mainly based on 5 components. Like for example, it need a hardware, and the hardware will be a computer. You can see it's a computer. Okay, you need a hardware like you know, CPUs, digitizer, workstation, and plotter, etc. And also, you know, the software, as I told you, in the market you will find maybe more than 100 software of GIS like this, because the software can be run on a computer. And the third one, you need a database because you need some satellites data, also some ground data which can be put in the background. Yeah, some satellite data is the third thing. And the fourth thing is, I would say, human, because you need an experts of GIS, which can work on GIS software. So an ordinary person will hardly work on GIS. So that's also one of the fourth option. And the final is policy procedure for resource management. For example, if you have a maps, or if you have the result, and if you have the output of the GIS, then you need the policy maker to implement the results, the results which you achieved from the GIS software practically on the ground. So actually, I would say that the component of GIS is mainly composed of five parts. Like you need the hardware, like computers you need, maybe you need the scanners, maybe you need the CPUs, or maybe plotters, etc. And then you need the software, different kind of GIS software. One of the example is this ArcGIS, so our ArcMap, where I have opened. Also, you need a data set. For example, you need a ground data or maybe some remote sensing data. For example, this is one of the satellite scene, Landsat scene of satellites. So you need the data, but you need an experts people, the fourth experts people. But when you have your results from the GIS, then you need the policy people to effectively, practically utilize the output of the GIS on the ground. Okay, so I think it's enough for today. We studied today a little bit about the GIS definitions, and also we did what's the cause of evolution of GIS, and also we also discussed about the component of GIS today. So like this way we will go proceeds, and maybe after at the second lectures we will study about remote sensing, that what is remote sensing. So hopefully the software, the GIS definition will be clear in front of you. But if you have any question, you can just write to me on my WhatsApp or on my contact detail. I will try my best to answer you. Okay, good luck, dear students, and have a nice day.